This is going to be a little video on how to do electron configurations from the periodic table. So again, your electron configurations are your 1s2, 2s2, 2p6. It's where electrons are located. And oftentimes we're concerned about the valence electrons. Remember, those are the outermost energy level electrons. So your periodic table is actually set up based on where electrons are located. This is just a blank periodic table, but it corresponds to the elements. So I put a few elements in here, hydrogen, lithium, and I've put the noble gases in, neon, argon, krypton, xenon, and radon. But otherwise it is blank. Okay, so if you notice on your periodic table, I've got some kind of dark lines drawn right there. They're there for a reason. If we think about our sublevels, the S, P, D, and F, well, first of all, let's go back. There are 7 periods on the periodic table. They're called periods or rows on the periodic table. Every row represents how many energy levels of electrons that atom has. So everything in this row has 4 energy levels of electrons. That also means their valence electrons are in the 4th energy level. Everything in this row, so these 2 elements and these 6 elements, all have their valence electrons in the 3rd energy level. So the 7 rows is based on that. The S, P, D, and F are this. This is considered the S block of the table. And there happens to be 2 columns. If you think about it, S's hold 2 electrons. So we put that where you guys can see a little better. S's hold 2 electrons. This is the P section of the table. Well, if you remember, P's hold 6 electrons, and there's 1, 2, 3, 4, 5, 6 columns in there, or families in there. This is the D block of the table, which holds 10 electrons, and there happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns in there. And this is your F block, which happens to have 14 columns. And F's hold 14. So the periodic table is arranged according to the electron cloud. So where electrons are located. Because electrons are so important in chemical reactions, that's why it is that way. And the properties of the elements are based on the valence electrons. So the first energy level has only an S sublevel. This is where it's a little bit weird. Helium really should be sitting probably right here. The reason it's over there is it is a noble gas. In other words, it has a full energy level, full outer energy level. Well, first energy level only holds 2 electrons. They both sit in the S section of the table, so this is considered the 1s part of the table. If we look through here, this is considered the 2s part of the table. So 2s1, 2s2. This is 3s, 4s, 5s, 6s, and 7s. So that's where electrons are filling in the S section of the table. This is the P section, so this is the 2p going from there all the way out to there. And again, there's 6 spots. So it would be 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, depending on how many electrons those elements have. This is 3p, again from there to there, 4p, 5p, 6p, 7p. Again, that whole section there is the P section of the table. The middle is the D section. Here's the weird thing about the D. The D is always 1 less than the energy level. So this is the 4th energy level. This is actually the 3D part of the table from there to there. So you remember the D's are 1 less. This is 4D, 5D, 6D. We probably won't get into the F's at this point in time, but your F's are 4F and 5F. And we'll draw a little arrow on your tables to show when those fill in. We probably will not get that far today. So when you write electron configurations, just follow the atomic numbers in the periodic table, and it goes in order. So the first 2 electrons go in the 1s, so 1s1, 1s2. The next 2 electrons, that's all that's in the first energy level. Next 2 electrons go in the 2s, so 2s1, 2s2. And then if you keep following your atomic numbers, this is the 2p, so 2p1, 2p2, 2p3, so forth. Neon would end in 2p6. That'd be the last part of it for neon. Then you fill in the 3s, and 2 electrons can fit in there, so 3s1, 3s2. Next section would be the 3p. Again, if you just follow your atomic numbers in the periodic table, and there's 6 spots for electrons there. After 3p comes this part. So this is a little bit weird. After 3p comes 4s, 4s1, 4s2. So if you're doing calcium, which is right here, it would end in 4s2. Those are its valence electrons. 2 valence electrons in the 4th energy level, S sublevel. So things get a little bit out of order now, but you just follow your table to figure out where they go. So after 4s comes the 3d section, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots for electrons in there. And that's your 3d section. After 3d comes 4p, and there's 6 spots for electrons. After 4p comes 5s. 2 electrons can fit in there. Once that's filled up, the 4d fills in, and there's 10 spots for electrons. After 4d, the 5p fills in, and there's 6 spots for electrons. After 5p would come 6s, and there's 2 spots for electrons. We'll kind of stop from there. So if I was writing electron configuration for, say, vanadium, which is sitting right here, that's vanadium. I just follow the table across. So first energy level, 1s, 2 electrons. Again, there's only 2 spots right there. Second energy level, you have an s section, which holds 2 electrons. That's 4 electrons we've done now. You have a p section right here, p sublevel, which holds 1, 2, 3, 4, 5, 6 electrons. So right now we're at neon. The next 2 electrons, the 11th and 12th electrons, go in the 3rd energy level, S sublevel, 2 electrons fit in there. Then comes the 3rd energy level, P sublevel, and again there's 1, 2, 3, 4, 5, 6 spots. So we are at argon now. The next 2 electrons then go in the 4th energy level, S sublevel, and 2 spots for electrons. If we're trying to get to right here, the next electrons would go in the 3D, 3rd energy level, D sublevel, and there's 1, 2, 3. For vanadium, it'd be the 3rd one over, so it's got 3 electrons in there. So it ends in 3D3. If it was 3D10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it'd be that element's electrons. Again, the valence are the most important, the outermost energy level electrons. Vanadium is in the 4th row, so its electrons are in the 4th energy level. So its 4th energy level electrons are those. Those are its valence, not the 3D ones. Its valence are those. The reason 4s fills in before 3d is 4s is actually a little bit closer to the nucleus because the shape of the orbitals make it closer to the nucleus. Electrons want to be closer to the nucleus if they can be. So you're going to follow your table to fill in your electron configurations. I want you to write the configuration for, I want you to do these elements. I want you to do tin. So write the configuration for tin, SN. And nickel. Oops. Nickel right there. Okay, tin and nickel. Write those 2 configurations.